There. Welcome to the SaturdayMP show, episode number 103, being recorded mostly live, June 15th, 2026. I'm your host, Chris. And as always, as usual, like last, I don't know, it's becoming pretty usual now. I'm joined by Omar, who had this crazy idea to. So a couple weeks ago, we wrote a custom. Oh, do I still have that open? We wrote a custom ping client in this god awful C code, which I thought I would like clean up and like actually open source the repo, but I just never got around to it. Because I even have all the notes for when Claude like suggested here's some improvements you can make. But we wrote a custom ping client that worked. It didn't actually listen for the response, but it built a proper ping packet. Like it created the IPv4 header, it created the basically the ping payload, and it all worked, which was really cool. We used Wireshark and everything to see it in action, and we got an actual response back. So Omar was like, "That's not enough. I want to write a low-level server in C, basically an HTML server." So that's what we're going to try to do today. Well, we probably won't finish it today. We'll probably just get some of it set up, and this will be a couple episodes. But we're going to try and write a low-level server, web server in C, and see if we can do it. So we're not going to go so far as to write our own payload, like IPv and TCP headers and everything like that. I think we'll be one level higher than that, but we'll write something that basically takes the URLs and stuff and correctly parses them out to return web pages. And maybe, I don't know if we'll fork another process, or if we have a server that's under load, maybe we'll do multi-threaded or something. We'll see how that goes. But so yeah, Omar, why don't you explain the idea a little more? Introduce yourself, explain the idea a little more, and then we'll get started. So
Sure. My name's Omar. I'm a web developer, software developer, and yeah, I because I've been working in web for a while now. I've been meaning to dig in a little deeper. They say try to go in a level or two deeper from where you're working to get some better, fuller understanding of how networks actually work. I was getting tired of kind of seeing the same patterns in every language I'm working in, where it's sort of like get an HTTP package from here or there, and import it into your project and work with that, as opposed to actually just knowing, well, what what is actually happening there? What is, if I didn't have access to a package theoretically, how could I actually make that happen? What kind of tools, what kind of understanding do I need to to whip something like that up under those constraints?
just to whip it up. Yeah.
Whip it up.
There's only people that
Yeah.
have like been writing web servers for years. Like, so I don't know. I think a basic one we could probably get working. That's all we're gonna do. But like actual web servers that deal with all the nuances of web, like Nginx or Apache or something, like those are software that's been around for a long time
Right.
and has lots of patches and fixes and all sorts of weird edge cases and stuff.
Yeah,
Uh,
that's fair. I'm sure we'll just be scratching the surface here,
yeah,
but
yeah,
uh, but I think scratching the surface is better than not even knowing that the surface exists.
yeah. Okay, so let's see how far we can get today. Because, like I said, I got a semi-hard cutoff, just because I got meetings this afternoon and I want to go for a walk because it's so nice out there today. Um, okay, so we got this. We don't. Everyone knows what this is. We'll just keep this README here. So we have basically a C. We have basic C set up on this Windows subsystem for Linux. And let's just see what we could do. So I guess the first thing, again, for people that are watching this is live. I'm not a C expert. This is just more for us to learn. If you have I guess no one's watching this live right now, but if you're watching this later, let us know. Let us know what you thought, or if you have some suggestions, or how you would write a custom web server in C, especially if you're a C expert, because I am definitely not an expert in C. Oh, do we do C or C++? I guess just C. Let's just stick with C, I guess, for now. Okay, so I think to start, I'm trying to think how I would do this. I haven't touched C in like, again, so long. Well, I guess a couple weeks ago we wrote the pink line, and that was god awful horrible code. So so what we need to do is we need to basically open a socket for listening. But we don't want to do, I think C probably has some built-in libraries. So we'll need to open a socket for, yeah, we need to open a socket for listening. That's probably step one. Right. And then step two would be parse the incoming request. And maybe oh yeah, usually we turn GitHub Copilot off here, snooze. And we have the clanker, we have other AIs we can use down below. Parse the incoming request. So like, I think in this case, what do you think, Omar? If we just served, like just returned a page, that would be probably consider that a success, eh?
Doesn't even have to be a page to parse like HTML. Like it could it could be like a I don't know JSON or um,
yeah, I guess it could be anything. Basically, we want a request to come in, and we'll just blindly return whatever they ask for if we can find it.
yeah or what would be simplest like a page or text or JSON or just like or blob.
Yeah, so now I have to, okay, maybe let me bring this over here. Okay. Sorry, let me log into some things here off screen. And then
Like a number, a status code.
yeah, there's always HTTP status code. So what I'm going to bring in here is, or I'm going to find so we got to look at the HTTP protocol and see. Oh yeah, I guess we're going to go with version 3. I guess 1.1 is still around. Oh, this is interesting. I didn't even know about this. HTTP 3 does not use TCP/IP, but QAC. I don't even know what QAC is. UDP.
UAC.
Oh,
Quick.
yeah, I guess so.
I like how you read that QAC, even though
Oh
there's
yeah,
no A in there.
yeah. I guess I just added that in there.
Nice.
Yeah, my wife would be so proud of that. Um, I don't even know what the quick protocol is. Oh my god. People can tell too we don't do a lot of preparation before any of these videos. Okay, it's supported in major browsers. Oh, interesting. It does this by establishing a multiplex connections between. Wow. I guess this must be more efficient than TCP. Oh, so it's got a lot simpler handshake. Because these handshakes are kind of resource intensive.
Right. So
So I don't know. I think we're just gonna ignore encryption for now too. We're not doing any of this low level stuff to start with. Uh, so let's need to set up an unencrypted pipe. Yeah, so like UDP is just kind of a one way, like you just send this message out and then that's it. You don't, you just like, if I remember correctly, you just assume it gets there. Where TCP IP will wait and see if people got the packets, and if they didn't, they'll resend it. Network switching events. Oh, interesting. Okay. Right. Yeah. The TCP lengthy process, like, because that handshake is so resource intensive. That's interesting. If you're driving like in your car and you keep hitting different cell towers. HTTP3. Oh, maybe we will need TLS. Okay. Browser support, client support. Oh, it's implemented in Go as a library, looks like. .NET 5. Oh, interesting. Cool. What are these? Implementation. Nginx, yeah. So Nginx has it. Does Apache have it? Probably. Uh, I don't see Apache in here, but I'm sure it's... Okay, so how do we... I don't think we want to write... So, can we open a QAC? Is there a QAC library in C? Probably. Initial hello. So it's going to send the certificate back. Okay. Okay, so maybe let's just start with step one. We'll just get a socket open for listening, and we won't do anything with it except write line something out. And then we can figure out how low level or high level we want to do for that, right? I don't know, we won't accept any arguments. So how do we want to, or we should do some organization, I think. I don't think we should put this all in one big file. So let's, do we call this server? Okay, well, first things first, let's just make sure I can compile this C app. So let's just write print f hello world. Great. And then here. Oh, and then let's steal that make file. I forget how make files work again, but let's steal it from the ping client. Okay, I'll just copy the whole thing and we'll clean it up as needed. Make file. Okay, so GCC The target is, just call it web server. Oh, we need a better name than that. Omar server? No. How do we need a cool? You got to come up with a cool name there for your server there, Omar.
How about um,
Hmm.
Scratch,
Scratch is already
Scrap,
programmable.
Scrappy,
uh,
Scrappy server.
Scrappy server. Okay. Main.c. So we run the target. What's our target? Scrappy server. Compiles the source, right? And we clean it. Okay, I think that'll work. So if we just go make. Oh, whoops. This needs to be this. I think I might have to pass the arguments in there all the time, right? Let's see.
Drop the link. We don't have to follow this obviously verbatim or copy it, but could be a just a guide to like, quickly reference. Obviously somebody's already done this before.
Oh, okay. Include. Oh, I forget how includes work now. Let's see. I'll take a look at your reference here in a second. Oh, pound include. Oh, right. I need the standard input output. Okay. Make. Oh, does this need to run as sudo? I'm going to say no for now, at least not yet. Okay. Oh, it didn't print anything out. Probably because I need. Is that what I did wrong? Oh, sorry. There is a hello world. It's just right at the beginning of the.
Yeah.
Okay, there it is. There. Okay, there we go. Cool. Okay, so that works. Let's commit it.
Nice.
Hello
You have to
world
have C
works.
installed, right? Is it the compiler?
Yeah, the GCC. Oh, I don't want
Okay.
to. I don't want to include this. Dot git ignore.
So Linux distributions don't have a C compiler installed usually by default, I guess so.
I some of them do. Yeah, but usually a lot of times you have to include the GCC compiler and libraries. So what do I want? I want a dot git ignore C. Generator. Does it have C? Yeah, okay. Okay. So ignore the object files, the linkers. It's all great. I should probably put this in a bin folder or something, eh? So I put that in a bin folder. Probably I think I could do this. Like this. Sort of a bin, I guess. This is the wrong slashes. Let me try that quickly. Okay. Oh, do I have to? No. Wait. Okay, so I have the target, Scrappy server. Let's call this path. So run. I don't know, let's call this build, I guess. So this will depend on build. I'm trying to remember how this works now. Build. Can I do this? Clean build. I think this is how I can do it. And then we'll just run the target path. Build. Okay, is that correct? Target pattern contains no percent. Number 10. Oh, I might have to ask the clanker for this. Okay, so we're not here forever. Oh, that's so gross. Twice get update make file to build. Okay, so oh, change it back. Oh, okay. Make the bin folder. Okay. Okay, cool. There we go. And it ran it. Great. Okay. How would I update the make file? I have to put like a build. Oh, okay. Build target path. Okay. So now I can just go make build. Yeah, nothing to be done because nothing's changed, right? So if you remember make files, it's going to go look at this source file, and if nothing changed in the source file, it won't do anything.
Oh, I see.
Okay, and then where's my git ignore? I'm going to ignore the bin folder. Okay, cool. So there. This we can delete. Ignore. Okay, good. Done. Now we have a basic C file. Hooray! Okay, so let's change this to I don't know, starting Scrappy server, and then in here, start server, and then we'll have a void start server, and so now we need to.
I wonder, can we use the socket code that we made from last time here?
That wasn't listening. That was sending. So
Oh, sending, right.
yeah.
Okay.
So how do we? So basically, we need to open socket on port. I don't know, what port should we pick?
8080.
8080. Okay. Um, okay, and then so we need to do that. And then we need to listen for open a port. And then we'll just print out what is sent to the port. So do we want to try and open? Like, I'm not sure how all this magic works. Do we try to open this new quick QAC? This quick.
QAC is great.
Do we try to open this quick port and listen for quick? Let's see.
So this replaces TCP/IP, is what
Yeah,
I understand.
that's my understanding too.
So is this easier to implement than TCP/IP? Is that the idea?
I don't know, probably harder, but beats me. Uh,
Well,
uh,
should we break this down further and try to tackle TCP/IP, or can we consider that out of scope for what we're doing here?
I would, if I was to do that, I would do something like we did for ping. Like I would just write an HTTP client,
Okay,
not a server. Just so, and
I
then we
see.
just send the raw TCP and we try to deal with it back and forth.
Right.
At the OS level, okay. Oh, right, runs over UDP. You open a normal UDP socket and the user space library. Oh, okay. but this does nothing quick related on its own. Oh, quick does a lot of things. Congestion control. Yeah, writing that yourself thousands of lines. uh, so
That's huge.
we'd have to write TLS. Stream multiplexing.
And that link I sent you, it looks like they're
Oh,
not
right.
doing, but I think they are using some C libraries is the thing. Like I think they're using a that socket library in C.
Let's see. Yeah, they're using TCP/IP. Bum, bum, bum,
Yeah.
bum. So they open a port. They wait for an incoming connection. They read the. Yeah, this is basically what we want to try and do. Yeah, and then you have to basically loop and wait when you get a connection, do something with it. In this case, they're spawning a thread to handle it.
Okay.
Yeah, we could build something like this too. Grid server socket. Yeah, so let's just open a basic socket and we'll see. I don't know if we'll do all this. From the server, the next subchannel, handle client, receive request data from the client. Yeah, throw it into a buffer. Okay, well, let's just see if we can get, let's just open a basic socket here. So,
Yeah, it seems like if you're there's a lot of magic going on with libraries. I mean, there's a lot going on,
yeah,
right? Like if you were, I guess that was kind of my question is like how crazy does this get without libraries?
like really crazy, really fast, I think. How is that
Okay.
different? And then you're binding. They picked port 443. Another question. Okay, let's just get a socket open and just spit out what it sends us. Right, so we're gonna need config the socket and then bind. Yeah, okay. inet. So if we're doing UDP, that's different than TCP/IP, which I think is a stream.
Yeah.
So if we were gonna do, we're probably better off just to do this as TCP/IP. Yeah, because that's gonna. I'm assuming a stream is that okay, but we're gonna have to include some headers here. Do do do, which is what's missing. So this would create. I don't remember what this AF inet is and stuff. Let's see. AF inet.
Seriously saying to use uh IP version 4.
Oh, okay. So this is Internet Protocol version 4. We could do for IPv6. Okay. And then I need which library did I have to include for that? Our ping client. I think we need this one, this syssocket. Yeah, okay. Expands to 2.
Syssocket.
Sorry, what did you ask, sir?
You need the syssocket library, I think.
Yeah,
Yeah.
this one here.
Yeah.
Yeah.
Okay.
And how do I see? Yeah, that's always an interesting thing. All right, so let's see. Can I see just for my own thing? So let's clear this. Please give me details on the socket call. The possible I don't remember what 0 is. Protocol? Oh, right. I think we put that to 1 for a ping client or something, didn't we? Oh, yeah, we set it to protocol raw so that we could write our own protocol.
Right.
Okay. Okay, so we want either IPv4 or 6. This is TCP/IP. Yeah, we should probably just stick with this, and then maybe we'll try the UDP. Raw. Oh man, raw is. We'd have to write our own TCP/IP, I think, then if we did that. Which I don't know if we want to do that. Let's just get this working with the streams.
Yeah. Yeah.
So let's do this. Yeah, you only set it for raw sockets. Protocol almost always it repeated itself. Okay. Yeah. So we have that. What does it recommend? No, it's repeating itself for some reason. Hey, Herc. Hey, Herc. Yeah, the port comes later with bind. Oh, okay.
What does bind do? I haven't done a lot of C, so.
That's gonna bind like listening on a certain port. So that's how we'll bind to port 8080.
Oh, okay.
Um,
That's like C doing network things.
all right, and C has to be in a certain order. I forgot about that. This has to go up here. The method has to be declared before it's used.
Okay.
Because C is not. Is that what that means? It's not a 2-pass compiler, just 1 pass, I think. Okay, so we're back here. Okay, we should probably add some error handling. This is what we didn't do last time.
Yeah.
Because I think this returns a file descriptor for the new socket or -1 for errors. Okay. L2 create socket. Do we just hard quit? I guess we just exit, eh? Or do we want this to return errors and then deal with it here?
I don't think we'll have time. If we're let's spike this thing up and hope for the best right now, and maybe come back and revisit
All right.
when we have more time here.
Okay, we'll just hard exit. Oh, do I need to declare this somewhere? What does this take? Oh, maybe they wrote a custom. Okay, let's just do this int. There. Okay, we'll just quit. Return integer. Germs. One on here. Okay. Okay, so that should create us our port. Let's just see if that compiles. Control.
Did you include standard library? The
For
stdlib.h?
no, I don't think I need it yet. So
Okay, because I think that's where exit failure and exit success come from.
oh, okay. Okay, that's fine. We're just returning an error if it fails.
Yeah.
Okay, so we opened a socket, so that worked. Now we need to listen on the socket. So this is where this bind comes in. So bind, bind, and then listen. All right, it's two separate commands. So what do they set up? They set up I think our clanker kind of wrote up the same thing. I got really confused here. Okay, how do I listen? Yeah, so we're going to bind to any port, set to port 8080. Okay. Oh, I probably have to include some library. And then we try to bind. If we don't bind, we fail. And then we try to listen. Okay. You need 3 more clues, right? Okay.
Yeah, so one of them is
Okay.
that stdlib standard library.
Yeah, I need to add the final one. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . 10. Oh, okay, interesting. Oops. Okay. Use before buying if you start your server often. In other words, hit address already in use. Oh, okay. Oops. So
So configuring the socket is basically adding the headers, right? That you know um, like the IPv4, TCP/IP. We're adding those to the socket. Is that right?
sorry, can you repeat that question?
Like when we're con like the configuration we're doing, right? Like which is right there. I think when you're going like add addr.sin family equals AFI net. So right here you're just like you're assigning that IPv4 header to the socket that you've created.
I don't know why we need this part. I'll have to look this up, but this is telling us what addresses we're going to accept connections from. In this case, we're going to accept connections from any address. We could limit this to only accept connections from certain IPs if we wanted to. That's what this is. Like the source address is where is this coming from? Where is the request coming from? So you could
Right.
limit it to only accept localhost. You could tell it to only accept requests from certain addresses, stuff like that. This we're saying anything. It can come from anything. And this one
Yeah,
is
that's like that same, it's like the origin policy, right? Like when you're dealing with,
like a firewall.
no, just like a client server
Oh, yeah, yeah, yeah. Anything that
and you get,
limits, yeah.
yeah, okay.
And then this is telling us we're going to use port 8080. I don't know what this does. This changes this into probably a uint 16, I guess, something like that. So this is setting all this up in a structure here. So this is a structure of socket address in incoming sockets. Maybe is that what this stands for? Some configuration. There's probably other configuration steps we could set in here.
That's coming
Um,
from a library.
yeah, this will come from, I'm not sure what library this one comes from, but it's probably maybe this net. Oh yeah, net init. Okay. It comes from this library here. So we have all those. And then this is that little bit that says for this socket, like let us reuse the socket address so we don't get the error when we try to bind to it.
Okay.
Yeah, we could probably set this to 10, but that's fine. And then so we're binding. So we're telling that for this particular socket, we want to bind it to this port 8080. So if I look at bind here, it takes the socket, the file descriptor. It takes all that address stuff that those properties we set up in that address. That's basically what these two are. We have to, and then because what we're doing here is we're passing it the pointer to this structure, not the actual structure itself. We also have to tell it the size of that particular structure because all we're doing is passing it the
Oh, I see.
pointer.
Okay.
So
Yeah. Yeah, okay, now we can sort of contrast and compare because what we were doing last time, yeah, like there was a lot of obviously low level code behind the ping. So each one of these would be or yeah, or just to come up to write that the header. Was it the IPv4 header that we wrote?
the IPv4 header, yeah, we wrote some of that,
Yeah.
and then we
Yeah.
also wrote. Where's the ping client? Um, yeah, so here we created.
ICMP.
Yeah, we created a raw socket. So
Yeah.
we're still using IPv4. We created a raw socket.
Yeah.
I can't remember why we had to set this. I don't know. I think something to do with keep it raw.
Okay.
And then we built our own IPv4 header here.
Yeah. Yeah.
So if you remember that protocol, we did all this here.
Yeah. Yeah, we had to do all the hex kind of calculations.
Yeah, so this is my source. This is like the Docker or the WSL IP address. And this was I think Google. We pointed this to Google.
Yeah, your machine was the host.
Yeah, this is my host source, and the
Yeah.
destination was Google.
Yeah.
We had to build this goofy checksum thing, and then we had to build the ping payload.
The ping payload.
Yeah, so we said, I think this was like the type is ping, and I can't remember. Oh, yeah, the sequence was like unique sequence, so we kept sending pings. This is our unique
Yeah.
identifier and sequence, so we knew when a ping request came back which one it was.
Right.
And then we built the whole buffer in a very inefficient way. And we printed off just for debugging and stuff. And then here we set up the socket that we're going to send on. So we're going to send it to the Google
Okay,
IP
interesting. We're using that
address.
same struct, right?
Yeah.
Yeah.
And then we sent that packet out. So we sent it out of this socket. This is the message that we sent. This is how big the message is. So a lot of things in C, you'll see like, here's what the message I want to send, and here's how big it is.
Yeah.
And then
Right.
I don't know what
You have
this.
to tell things what the size is.
Yeah, I guess that's just flags. We didn't send any flags. And then we sent we sent oh, this is a destination. So this is the destination we want to send to socket settings. So this is us telling us, hey, we want to, over this socket, we want to send to Google and we want to use IPv4. That's
Yeah.
what this is telling us here. And then we would see how many bytes were sent. And if it succeeded, this is how many bytes we actually sent. And then we didn't actually listen for a response in this app. We just sent it and we used Wireshark to see. If you remember, I had that other
Right.
program open.
Yeah.
Yeah. So we used Wireshark to see what came back. And then once it came back successful, we were all happy.
Yeah. 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 Yeah, because we couldn't really tell first which connections were which requests were going through the network. I think that was part of the initial problem, and then I think you realized that it was an admin issue in
Oh,
Linux.
yeah. I had to run it as sudo. So I don't know if I'll have to run this one as sudo or not, but
Right.
we'll have to see. Okay, so we start the Scrappy server. Okay, let's just double check that this works. Okay, so it all looks like it works. Now we need, so this is basically, this isn't really start server. This is more like
configure. It's a configuration going on here.
Yeah. So let's call that like let's call this bind. Let's call this open port. Turns the file descriptor
Or like bind to port. Yeah.
or -1 if error occurs. Okay, so we'll just open that port. And then the start server. We could do int equals bind. What did I call it? No, open port. Just return. Okay. So we'll open it. So this will be like set up the port and listen. Then we need like loop until we get a message. So how do they set all that up? They just have a while one loop. So I don't think we'll even loop for now. We'll just ignore the looping. We'll just wait for a message. So I think we can block on this. This way the server can handle multiple. Yeah, I don't want to. Handle client. Accept the connection. So we'll have to set up the source. Yeah, we have to set the length and everything again. That's so goofy. Okay, so let's double check here. Clear. So how do I accept an incoming connection? For now, don't get fancy. I just want to accept one connection. And it can block. Kiss. See if it knows what kiss means. Okay, how do I oh, I should have committed my last changes there. Let's do that real quick. Okay. Opening to a socket. Let's put width. Just call accept. Oh, instead of this. Oh, okay. Oh, I didn't mean to. Oh, you made the changes. Great.
Yeah, I was gonna say I felt like it did, but I wasn't sure.
Son of a gun. Oh, can I undo these? Oh, dang it. I didn't commit that soon enough. Okay. All right. Oh, no, that's okay. Yeah, so it opened the ports. None of this changed. Oh, okay. I think we're okay. Refuse, so we don't use it. Yeah. Start the server. Printf client connected. Yeah, that's basically what I do. Well, we're going to actually want to print out the message, but this is a good test. So we take the socket. What other options are there? Oh, this is like open a socket to communicate with it. Set is the address length belong to the address of the connecting peer. Okay. Yeah, then we got to close the connection. We got to do this, and then we're all done. Okay, well, let's see if this works. Okay, so we paused. Now, I guess what I can do. Oops, no, cancel. I want to. Sorry. Let's go here. Do I have Telnet installed? No. I guess I could just curl. What is the IP address? I should be able to do curl localhost 8080. No? Did it? Okay, so it did connect, but we never returned anything, so curl just bailed. Awesome.
Right. Okay.
Yeah, so as soon as it connected, we just sit there and wait. Did the accept fail? No, client connected. Okay, so that worked. Oh yeah. Okay, so that's cool. Let's
return something, right?
okay, so let's print out. I think the first thing we do before we do that is let's try to print out what was sent to us.
Okay.
Because we have to parse, because parsing what is sent to us is going to be a bit of a pain. Because this is C. We probably have to like read the bytes or something like that. We can't just
It's no method. No quick method.
yeah, so accept. Await a connection on a socket. When a connection arrives, open a new socket to communicate with it. Okay, and return. I fully don't understand what this is saying. So when a connection arrives, that's fine. Open a new socket to communicate with it. Set the address to the address of the connecting peer. Oh, okay. So this is the, I think this is the IP address of the person connecting to us. And return the new socket descriptor. Okay, so this would be like, what do we want to call this? FD client. So this is, maybe we'll call this FD server. or server file descriptor. This could be the client file descriptor. This one should be the server. This didn't open properly, so we don't care about it. And this one. Okay, let's just double check that this all still works. All right, cool. Okay, good enough. So, how do I read this now? I have a file descriptor. Is this making sense mostly, Omar? It's kind of making sense for me.
I think so. Yeah, I mean, there's still obviously a lot sort of going on with each one of these blocks that would necessitate some maybe deeper explanation, I think. But
Okay. How do we know that buffer size? Okay, so it's just a file descriptor. Oh, so we can read it like a file. Okay. So client connected. We make that buffer size. And of course we have to null terminate it. No, we'll manually apply the edit. Okay, so why did it pick this, I wonder? I'm just gonna ask it that. Why? I'll just ask it like this. Okay. Don't overthink it. Okay. Because we probably have to read this. Like right now, we're just reading one big chunk. We probably have to read this in a loop or something. Okay, so we're reading from the client socket. We're putting the results into this buffer. And we're only going to read, so we don't have buffer overflows. We can only read until the size of our buffer -1. The reason we put the -1 in there is that we need to put a null terminator on the end of a string. Otherwise, when we print this string, we're going to get a buffer overflow here.
right.
So, yeah, you know how strings work in C, right?
Yeah, I mean, it's like it's all bytes at the end of the day. Like characters, they're made up of characters, and each character is like a byte.
Yeah, but I guess we could do a little demo of this here too. So the way printf works is you pass it like an array of bytes, like characters. And what
Right.
it will do is it will keep printing those characters until it sees a null byte, which is like all
R-
zeros. So if it doesn't see that
Right.
null byte, it'll just keep printing like happily until the end of time. And then you're going to
Yeah.
get a buffer overflow. So let's try running this once with what we got, and then I'll comment out this, and we can watch this crash. If I,
Okay.
it's assuming everything's correct. So I'm not sure what curl's going to send. Let's see. Got an empty reply, which is fine. Okay, so client connected. So this is what curl sent. It sent get HTTP1. This is the host, user agent. And I'm not sure what accept means. Accepting anything, I think. So, and then a
Okay.
couple blank lines, and we didn't respond. So curl is expecting us to respond, I think, with a web page or something like that.
Right.
So now if we, I bet you if we comment this out, this is going to crash. Oh, it didn't. Oh, maybe it sent, maybe it puts that in there. Okay, let's make this really small. Let's just try 5. Oh, we could be getting lucky too because we're not reading. Yeah, we're not reading the whole. Let's change this to there. It might just be getting lucky. I want to make it crash. Oh, why can't I get it to crash? Oh, this is really sad. So I read this buffer. No, I want you to die a horrible death. Okay, now I tried to do an example for you to get it to crash. You know, if I was just writing this, it would probably crash like nobody's business. Okay, why can't I get this to crash? So I'm saying the buffer is 2. So it's printing out GE. Maybe there's already like the next line is already a 0. We're just getting lucky.
Yeah, I mean, I understand what you're saying. Like that makes sense. There has to be it's looking for that null value
Uh,
when it's printing out. This is in printf, right? So it's when it's printing out
yeah,
the in the terminal, right?
yeah, we must have zeros. Okay, so let's try the uh, I don't know. Set it at. Oh wait, can I just do A? Can't remember how this. All right, does that work? Oh no. Oh, char star. How do I slash B? How do I make? Is it just single quote? I don't remember how to make a character again. Right. Yeah. Okay. Single quote. So what would this do? Oh, interesting. Does this read? Does read put slash n on the end of my read n bytes from buff into buff from FD, return a number read. Yeah, now I can't even get this thing to crash. This is so annoying. So if I read 10, that's going to go from 0 to 9. Oh, this has to be 10. I think there's a problem. Oh, yeah, okay. So there's the AB. So we're just getting lucky. There must be like a null. This buffer must be have a null terminator on there.
Mhm.
So what I did is I set this buffer to that size. I set this value at space index 10 to A, index 11 to B. But down
But
here, I only read 10 bytes, right?
yeah,
So 0 to 9 would be this get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So 0 to 9 is going to be get HTTP. And then because we didn't put this AB, like because we didn't terminate it properly, it just kept printing off whatever it found in that buffer.
right.
So if we put this back in here, we won't get the AB anymore. This will end it because this is how many bytes were read, this N. So if we null
Yeah.
terminate it, we won't get the AB anymore. I think. Hopefully I did this right. Yeah, there we go. So does that make sense how strings work in C?
This just happens with buffer? Like, what if like forget buffer and just make a string and try to print it and like with what happens then? Do I still need to worry about the always having a null value as the terminator when it's reading when it's printing a string?
Sorry, can you say that
Like if
again?
I'm just forget buffer, I'm just I'm creating a new string, and I'm gonna print it using printf. What's
Like this?
yeah, like is that why I'm adding that slash n at the end? That's new
That's
line,
a
I
new
think,
line.
right?
Yeah.
That's a new line.
Yeah.
So this isn't applying here with the null terminator. It just prints the string.
Yeah.
Like I'm
So
not, it's not
I think C itself is smart enough to put a null terminator on the end of this string when it sees it
okay.
hard coded like this. But if it's just a
Okay,
red,
but here because you're going a level down in terms of now you're creating that array, that character array,
mhm.
as opposed to just letting C do that. You're doing it, and so now you're handling this kind of um this behavior, right?
Yeah, yeah.
Yeah. Okay.
So it's the same thing if you read from the input. Um,
From a memory address. So yeah, so it's like so if I knew the memory, so if I assign a string to a new variable a or a string, right? str equals, quote ABC, right? And then I know the memory address of str. I should be able to find that null terminator, right? Because it's presumably it's an array, it's a byte array, and it's these values are contiguous, right? A, B, C, each one is stored in a each one is a byte. So we're gonna,
mhm.
there's gonna be 8 bits for A, 8 bits for B, 8 bits for C, one, next to each other, right? In memory. And then after all that, there should be a null value. I don't know how is a null value also a byte?
Yeah. It's just
Takes
zero.
up a
It's just
byte.
0, 0, 0, 0, 0, 0.
Yeah, yeah, okay. So we should see that if we're um uh going to the if we know the memory address and and we can print and we can see the values that are stored in there.
Oh, okay. So
That's
you
what we
want
should.
you want to do something like this, right? Create a string ABC.
Yeah, right.
and then printf at 0, right? Oh, I guess we should put a /n at this. We
Well,
have
printf at
to,
0 here, that's just going to give me A.
yeah. So is it %C? You want to see what values at 0, 1, 2, like at 3? If this will automatically create a null.
Yeah, like yeah, like if I know where they are and where this is stored in memory, where str is stored in memory, right? Then I should be able to uh look at that last byte, and that should be the null terminator.
Yeah. So how do I print this off as an, so like if I did this, so this is printing off one character and then a new line, right? And it's
Okay.
using our string, and we're going into index 2, so 0, 1, 2. So let's just print off C. So you can see that there. And then if I change this to 3, like it's basically, you're not going to see anything because it's null, but is that what you were asking?
Yeah, I'm imagining what I can see in memory here. Like if I'm seeing well, that could be interesting. Could you actually see, is there a way in, I'm sure there's a way to see like the bits, like to see it in bits
Okay,
and
yeah.
bytes?
Let's see. There's probably a way to, it's probably printf. Printf has a ton of arguments. Um, oh no, I guess I gotta write my own. Okay. Okay, well, we could just write one here. We'll just cut and paste this. Right, so we're taking a character, and then, oh, they're masking. Okay, so they're masking the bits. Yeah, and then so it'll print off what it is, I think. So let's see what this does. Print bits. Semicolon there. This is string. Okay, let's see if this prints off the right thing. Oh no, it didn't look like it printed anything. Oh, do I need to flush the buffer? And then flush the buffer. Okay, yeah, I just need to flush the buffer. Okay, so does that C? Let's see, ASCII chart. So we have, where's C? Printable characters. That was a lowercase c. So that's this one. Yeah. So there, it printed off that one, right?
Right. Yeah, yeah, right. Of course. Yeah. It's the ASCII.
So we could do for I equals 0, write it like this. I less than 4 I plus plus. Oh, we could even do this up to like 6. So I'm curious what we're going to get. So this is going to go over the edge of the string, right?
Yeah.
So we should get A, B, C, null, and then who knows what we'll get after that. It's anybody's guess. All right, so there's A, B, C, the null, another null, we're lucky, and then whatever the heck that is. So
Yeah.
we're into some other chunk of memory there. So
Yeah. Okay. Okay. So you're saying that if there wasn't that null, so C does this. Yeah, obviously C is doing it's adding that null for you.
when you declare a buffer like this, it will automatically add it for you.
Yeah.
If you declare your buffer like this, stir2, I don't know, let's say it's 3, right? Who knows? It's a crapshoot what could be in here. Like this is unassigned, uninitialized memory. C doesn't initialize memory for you. It doesn't null terminate this.
Okay.
So we could even try, we could put this in a for loop. Let's see what's in there. This could be just garbage. I don't know. So this is the, yeah, look, it's just whatever garbage is in there.
Yeah.
So now if I tried to print that whole thing, like just the printf.
You're printing both, so do we want to be printing both or just focus on the one you're doing right now? Because you're printing the one underneath too, right?
Yeah, this is garbage, garbage, garbage,
Okay.
garbage. 1, 2, 3, 4, 5, 6, and then we start A, B, C, null, and then we buffer overflow.
Buffer overflow?
Well, yeah, because we're going outside the bounds of this array. So
Right.
when we get to here, we're in some other memory.
Yeah.
Because this is all string. This is string 2 from here, or string, the original string right here. Right, but this is A.
And that will crash a program if what? Like like this buff like when it's if it's searching through a string or trying to print, I guess, yeah, like
Yeah.
it's if it's trying to print these characters or the string.
Yeah, so eventually, if you try to read memory that's outside of this program, a lot of times the operating system will kill it. Printing whatever's there often won't kill, well, sometimes won't kill your application unless your string just keeps going forever. So like if we
Yeah.
tried to, I don't know, let's try to print 200. I bet you that'll crash, maybe. Oh no, it didn't even crash it. It just kept printing it. Eventually we're gonna hit the edge of the, oh wow, we didn't even hit it there. How big of a thing do we have to keep going? 10,000? I don't know. Apparently 10,000 works. We just keep printing memory off, so I don't know what garbage we're finding. So
Okay.
are,
Okay.
are we
Interesting.
looping around the beginning? Oh no, this is just, oh no, it's whatever. It's whatever it's finding in these memory things, I think.
But why is it all of this stuff is it's finding it in that array, like in those in like it's because you didn't determine the size of the array.
No, well, so C basically when you ask this, C will be like, hey, get me an array that's 3 bytes or 4 bytes long.
Hmm.
It probably gives you one that's slightly bigger because just for memory allocation and stuff, but like it's going to give you an A, So it's going to get you 4 bytes. There's like a memory call in here, like a malloc call, kind of
Right.
implicitly. Or I think this has something to do with like C in the stack. Like this is just going to dump this hard coded value onto the stack, which is different than malloc, I guess. So I think we're just reading the stack. Maybe that's why it's just repeating.
Okay.
So yeah, this puts the okay. I have to remember. Just you're asking a lot of hard questions now. But this is hard coded, so this will put it on the stack. Same thing here. This is going to create me an uninitialized array of 3 and just put it on the stack.
Yeah.
And then who knows what's going to, yeah. And then when we're reading here, once we get past the end of this array, like who knows what we're going to print off, right? So, but eventually you'll try to access memory that you don't have access to, that your application doesn't, and that can crash your app. Yeah, ABC, and then yeah,
Yeah,
who
so what I'm
knows?
saying is it's obviously gone far beyond the length of that string. Like
Yep.
it knows, like doesn't know, but okay. I mean, we know that this string is of length three characters. So there's 3 bytes in memory somewhere, 1 byte after the other, right? And then but it's just it keeps going to just other places and like the rest. So it's when you even because it's not even an array at that point, right? So it's not contiguous. So maybe going to other locations randomly, like that
No,
aren't next to each other, like
no,
not
these these
addresses that are
these
next
are
to each other.
in this particular example, they'll all be next to each other.
Even after it's finished, the that like that's what I'm saying. So it's actually treating it as like this big array that doesn't end.
Well, in this case, we're just printing off each individual byte. So we're not doing a printf. Like we're just saying,
Okay.
hey, the byte at 0, what's in there? And it'll show us what's in there. Printf will
Yeah.
stop when it gets to here. So if we did a printf on
Right.
this string ABC, it'll stop when it reads this one. What we could
Yeah.
do,
So you're still going like to, index 4, 5, 6, 7 to index I, right? So it's just going to each value in the neighboring address. Like it's going to each neighbor. It's like, hey neighbor, what's going on in there? What value do you got in there? And it's just going and going and going and going.
yeah, yeah, like this, like yeah, C is pretty dumb. It won't. Yeah, we're just saying, hey, here's so all this really does is it tells you this str variable just tells you, hey, this starts here. It starts at this memory location right here. That's all it's really telling you. It doesn't tell you the end. It just says
Yeah,
for this chunk of memory, it starts here. If you index into index 2, like index 1, that's this one. Index 2 is this. Index 3 is here. Index 4 is here. But again, it doesn't have any, C doesn't have any idea that we only allocated an array of 4. So
that's what I'm getting at. Yeah,
yeah,
that's what
it'll
I'm saying.
happily let you access outside. Where other languages, like higher level languages, when you try to access outside the array bounds, they'll throw an exception, right?
Exactly.
Yeah.
Exactly.
Oh, okay. So that's
Yeah.
what you're asking. Yeah. Okay.
Yeah.
So let's just see. I'm curious. This will probably uh, printf. Will this crash? Percent percent s slash n. Okay. So what I've done here is I've created this pointer, and I'm pointing it to the string, which remember starts here, but at index 5. So which will be here. I don't know if we run this program again if this will be 0, but it's going to basically just print off all this crap that it finds. So I'm curious what this is going to do. Oh yeah, there we go.
And that should be the same, right? Like, no, it's not going to change each time.
Yeah, this memory, this is unassigned. Like this memory can be whatever. Like who knows what it'll be.
Right.
So here what we did is we printed off the 10 bits. So A, B, C, null, and then whatever garbage
What
came.
happened at the end there? Is that,
So this
but
is
that doesn't,
okay, so like I was saying, yeah, I'll try walking through this so you can ask a question after. Is we have this array of 4, right? str. So we print
yeah,
off, and
yeah,
here we're just going to print off the first 10 bits of this array. Even though it's only length of 4, we're going to print off 10. So we got A, B, C, null. And then this
yeah,
one, just one happened to be null. And then this garbage, whatever's after this, right?
right,
So, and then down here, what I did is I said, hey, give me a pointer to the 5th index in the string array. So that's 1, 2, 3, or sorry, 0, 1, 2, 3, 4, 5. So it's going to start here. So this pointer
right.
points to this piece of memory here. And then I
Okay,
said, hey, print off the string that you find at this pointer. And that was the
yeah.
gobbledygook at the bottom. Because
Ah,
so it's going to start printing whatever this is. Apparently the first one's a colon. And then these are all probably unprintable characters. And then eventually there was a null, so it stopped past the ones that we had written here. But it printed off all these unprintable characters, and it found a star, a Z something. I'm not even sure what that is. And then an M. And then it finally stopped because there must have been a null somewhere in there.
right.
So yeah, so printf with a string will just print, it'll just print until it finds a null. So
It likes to just keep printing.
yeah, that's what it's designed to do. Okay,
Okay.
so we can get rid of all this. All right, this seems like a good time to wrap it up.
Yeah.
What changes do we have here? Oh, print bits. I can get rid of that too. I don't need this anymore. That was just for a fun example. Oh yeah, okay, cool. No changes. Well, I don't know. That was pretty fun so far. So maybe if we do this next week, we can try to parse out what the client sent to us and return it. So like when we sent that curl command, right? So curl wanted, so it said a get request, get me the file at the root folder using HTTP 1.1. Return it to, oh, this is where it's sending it to. It's just saying it's curl. Yeah. But this is the important part right here. And then so we'd have to parse this out and then return a proper HTTP response, which would be like, code 200, okay, here's the page at slash.
Right.
Yeah, so we could try doing that next time. That'd be kind of
I
cool.
like it.
All right. Well, yeah, thanks, Omar. You always come up with good, with fun ideas. Thanks, everyone, for watching. Hopefully, we'll do a part 2 next week. And the summer vacation's coming up. We might have to cancel some of these because I'll be gone. Or maybe we'll pre-record them, or maybe Omar will do one by himself. I have no idea. But yeah, thanks for watching, everyone. If you have any feedback, put them in the comments or ask at SaturdayMP.com. And yeah, like it, subscribe it, share it, give us feedback. Yeah, we love hearing back from people. We love doing this just for the heck of it, but it's always nice when people respond because I can't see your beautiful faces out there. Like when I do a live presentation, I like those. I'm getting used to this, but live presentations I find are a lot better because then I can get people's feedback and see if they actually like what we're talking about or not, stuff like that. So, yeah, any last minute thoughts there, Omar? Or should we wrap this up?
I think this is really interesting, and yeah, I would love to deep dive here. when the opportunity arises.
Yeah, maybe we should reach. There's a couple other people that we know in our community that are much smarter at this level of stuff. Maybe we'll have to reach out to. I don't want to mention any names on the live thing, but maybe we can reach out to them, see if they can explain things better than me and the clanker can. So maybe we'll have to do that. So yeah, well, thanks
Yeah, I
for
think this could be a series in its own
a
in
series
its
in
own
its
right.
own. Yeah. Yeah. Well, thanks for watching, everyone. And we'll catch you all next week. Take care.